Good morning, everybody, and thanks for joining for today's webinar. We'll give folks just one more minute to join in here and we'll get going. All right, well, let's get started. Happy Wednesday, everyone, and thanks for joining in on our webinar called Reduce Connection Design Time by 80%. So the goal today is to show some interesting new ways, hopefully, that you can save time with IDEA, whether you're a new user or you've been around for a while. Hopefully, we're showing a little bit of interesting tips and tricks or ideas for the whole group, whether you're new or you've been around for a while. So that is the goal today. And let's look at the quick stuff here with GoToWebinar control panel. On the right side of your screen, you can see where you can input questions. There's also the PDF handout that's available there. So if you click on that, you can download all the slides from today. And also want to mention, we do always record this webinar and post it on the website a few days later. So if you're looking for the recording, wait a couple of days and go check our website under webinars and you can find all of that there. Agenda for today. So first we'll do a quick IDEA StatiCa intro for folks who haven't learned too much about the software. We'll kind of talk about what tools we have and what we do as a company. Then we'll get into the meat of the presentation, which is really looking at these 5 ways that we have to reduce connection design time. We'll be mostly focused on steel connections today. That's the goal. And then we'll also look at version 25.1. We just released a new version of the software a week or 2 ago and have some new features we want to talk about in there. So I think Johan will tell us about that. And then we'll go through a quick Q&A. So looking at IDEA StatiCa and what we do as a company, we're a software company focused on structural engineers. We make tools mainly for the structural engineering field. And we focus on creating tools for designing structural details, we call it. So that can look like a few different scenarios. The one we'll talk about today is connection design and using FEA in combination with code equations to design connections from very simple equations to more complex scenarios. We also can design steel members looking at different scenarios with interesting loadings, openings in members. We can actually model in the end connections on those members, handle certain situations that are a little more complex or a little more interesting than what you might be able to design in your current general analysis software. And then we also have a whole concrete side where we're interested in solving scenarios that range from anchoring cases, looking at breakout reinforcing, to deep beam designs, walking columns, openings, penetrations, all those kind of things. So with that, today I have Andrea and Johan joining me, 2 of our product engineers. They're going to be talking through our 5 ways to reduce connection design time. So with that, I'll hand it off to Andrea and she can take it from there.
All right, so let's jump into this presentation. Together with Johan, we're going to present 5 ways to reduce connection design time. This presentation is for people that haven't used IDEA StatiCa, for those that have used IDEA StatiCa and have less experience, and also it will help some experienced users to learn some new tips and tricks. So let's start with the first point, where I'm going to show you how you can save time by using IDEA StatiCa Connection to design connections versus traditional methodologies like Excel and hand calculations. Okay, let's imagine you have to design a connection between a beam and a column. These are the forces that you need to assess. This is a LRFD load combination. And in this case, I decided that we are going to design an end plate moment connection. Okay, so let's jump into the software so you can look at the general workflow of IDEA StatiCa. Okay, so now let's open connection application from the IDEA StatiCa launcher. Then let's start defining the geometry. So you can see that we also have different geometries and different parametric templates. I'm selecting the end plate parametric template. Now the model is open. You can review the different views that we have. Then I am changing the cross section because this parametric template has some previous selected beams and columns. So I am changing the sizes to the sizes I need. So I am doing the same with the beam. After that, let's work on in the connection. As I mentioned, this is a parametric template. So a parametric template is a coded connection. So basically, we coded some parameters in this template to easily modify this connection. Okay, so you can see that's really easy. There are some few parameters, and you can turn on and off stiffeners, for instance. But what if I want to modify this operation and add more bolts? So the workaround in this case is to explode this parametric template, and now the end plate is available to modify. Okay, so this can help me to use the parametric template as a starting point, and then later come here and use the operation and modify all the parameters that I need. Okay. Now, after setting up the geometry, I can jump into the load effects. I am deleting this to keep everything in 0. And now I am inputting the forces we had or we set up for this example. Okay, so we have a moment force and then shear force, and then finally we can calculate. So we set up the geometry, we set up the connection, and then we run the analysis. After this, it's important to review the results. You can see that some elements are failing, okay? But the first thing to do is to review the deformed shape. You can see the hot spots, you can see the most stressed part of the connection. In this case, the column has the worst stresses. So what I'm going to do is increasing the thickness of the end plate and then adding some stiffeners. Okay, so I am adding those stiffeners and then rerunning the analysis. Now everything seems that it's passing, but it's important again to look at the deformed shape. This is my sanity check that this is okay. Okay, so we finalized our design, and these are the results. Everything was complying with the code, and this is the final design of the end plate. But let's imagine we got a call and we have a change. So we need to change the column section to an HSS 10 by 8 by 0.5. So let's see how we can change that in IDEA StatiCa and how long it takes us to do that change and review the design as well. All right, let's jump into the software. Now, in this case, I'm copying this connection in the same file, and now I'm going to change the column cross section. I am selecting hollow section and then finding the HSS 10 by 8, and then changing the material to A500 grade C. You can see that now stiffeners cannot be added to this HSS, and then I am changing the connection from bolted to welded within the end plate operation. This is possible in the same operation. I did that change, and now I am running the analysis. So let's see the results. Again, everything passes except for the weld from the end plate to the HSS. We can go back and then look at the stresses. You can always look into the welds table, bolts table if you have bolts. In this case, we just have welds. So I'm going to go back and change the size of the weld. So it was a filled weld of 1/4. So now I am changing it to 5/16 and rerunning the analysis. Now the welds are 92.6% of utilization for the worst case, so everything looks okay here. Okay, so we saw that that change can be very quick. You just change the profile section, and then you review the design, review if everything is complying, and then modify as needed, right? So this was the final design of that connection that it took us like less than 2 minutes to modify it and review the design. So now let's take a look at the process of designing a moment end plate using the AISC Design Guide 39 procedure. So I am taking these screenshots from that design guide. You can review them there, but this chapter summarizes the steps to design it, and it's kind of a summary with equations that you need to use to design an end plate. So this is for a flush end plate, and you can see that it's divided by the end plate and bolt design. So you have the different equations for that, then for the welds, and then the column side limit states, right? So in the next page, we can also see some parameters that you follow and more different checks. So you will need to use all these different equations either by hand calculations or in your Excel spreadsheet, right? So, but what about the case where you had the HSS column? There are not too many guidance, and if they are, of course, you need to find them and then create your own spreadsheet and design this connection. So I summarized the connections that we look at and how it's going to be different from calculating these connections using IDEA StatiCa, and how long it will take by using hand calculations or Excel. So the first two lines, we have the W beam to a W column. With hand calculations, I'm calculating, or I'm thinking about 1 to 2 hours. You can agree or disagree in the chat or in the Q&A. Feel free to put your comments there, and we can discuss that during the Q&A. For the W beam to W column in IDEA StatiCa, as you saw, for a new user, it can take like up to 10 minutes, or let's say 15 minutes, right? But then for an experienced user, it can take up to 5 minutes, right? And then I am also showing the second case with it, that it was like a W beam to an HS column. Again, I am putting 2 hours for hand calculations, and then you saw it that with IDEA StatiCa for a new user, it can take up to 5 minutes or 2 minutes if you are experienced users to do that change of cross section, and then reviewing the design, which is the most important part. Again, this is an approximate comparison, but let us know what you think, and you can also try out by yourself to prove this time savings with IDEA StatiCa. All right. Okay, so now let's jump to the next example. Okay, so now for the experienced users, I have here a summary of operations that will help you to speed up your modeling skills. I suggest downloading the presentation and go to the different links I input here in the more info link, and you can learn more details about the usage of these operations. Okay, so now let's start with the stiffening plate. So one of the most used operations is this stiffening plate operation. You can see here the icon, because this helps us to reinforce members and use it to model a custom connection. The trick is to locate the plate related to another member or another plate, instead of locating it using the X and Y coordinates. So the trick is to select origin, and here you will see different options: member, member local axis, plates, or the first option is always the joint. So to avoid, like trying to figure out, like the position, the exact position of the X, Y, and Z, you can just set it up as a doubler of a plate. For instance, this plate is a doubler of the web of the column. So easily it will be located as a doubler of that plate, right? So here you will find more information about the different options to locate the steel plates to another part of the model. The second operation is the stiffening member operation. So you can see here the icon, and this will help us to use a cross-section to model a part of the connection. For instance, in the example, is used to connect a portion of the shear tab to a girder. So this member or this beam needed to be down like for 4 inches from the girder top of steel, and then we use this stiffening member operation to weld this portion of the shear tab, right? Again, you can also locate this stiffening member operation from another member or another plate by using this orient option. The third operation and trick is to use the member cut operation to extend the so this will help us to extend the member for an end of the column connection. So for instance, here you set up the geometry beam to column, and when you don't have any connection, this is connected through the center line, right? So the node is over here. So you would like to have this M1 extended until here. So my suggestion is always to use a member cut operation and use the extend member. Instructions for using that operation are in this link. Now, I want to share some tricks using the following tools. The first is the measure tool that will help you to get distances between corners, edges, and surfaces in the model area. So you can activate this from the small icons in the application, and then you can select the different edges, surfaces, or points, and then get the information in the 3D model area. So this was released like 1 year ago. So if you haven't used the application or if you're new to the software, this is fairly new. Okay. The second tool that I want to share with you is the online share file that will help you to share details or 3D models or 3D views from your connection model in IDEA StatiCa Connection. Now in the app, we have this button that will create a link, and then you can share that link to other people. So for instance, your clients or other colleagues that are not IDEA StatiCa users, or they don't have any license. So they can go to the online viewer. Well, they will click on the link that you shared, and they'll go to this online viewer, and then they can see 3D, the 3D model of the connection, okay? And that is a free tool. Okay. Finally, the section view tool helps you to generate quick sketches from the application and show them in the report. This contains important information about details coming from your connection model. So that will contain distances between the bolts, dimensions of the plates, weld sizes, and the type of bolt that was used. So this is really useful when generating reports and getting these quick sketches from the connection. Okay, now let's keep sharing some information to users. So I gather 3 rule of thumbs for the boundary conditions in IDEA StatiCa. So this will help new or existing users to speed up the boundary condition selection. Okay, let's start with the model type. Every member in connection application has a model type configuration. The rule of thumb that I use is that you always use the first model type, which is MBY, BC, MX, MY, MC. You can see it here. Unless the next 2 options. Your member is a bracing member. That means it was designed only to get axial forces or shear forces. So then for that case, you use the 4th option in this list. Then the second point that I have here is that, for instance, you know that your beam, and you are sure that that member or that beam will have a restraint. For instance, stiffeners along their length. So in this case, this is not a stiffener, but it's this beam, this main beam is stiffened by other beams. So their major axis is stiff, right? So you can now use one of these model types, the second or the third. So basically what you're defining with the model type is their degrees of freedom of the member. If you are not sure about these 2 points, then you use the first option, okay? So now let's jump into the second rule of thumb. So this is related to the force position. Similar to the previous rule of thumb, all the members in connection application have the force position input. So that will be in the member setup. So first of all, let's mention what is this. The force position will shift the member force along the member's longitudinal axis. My rule of thumb is that this input will be relevant when the member has only shear forces, because that will affect the moment diagram developed along the member. So this is the rule of thumb I use, but if you want to learn more about it, you can always go to this link and learn more about this this input. But this is the rule of thumb I use when reviewing models. If the member has only shear force, then we need to look into the forces in, and we need to specify where to locate that shear force, okay? If the member has moment forces or axial forces, then it's fine if we keep it in the node, okay? Now let's go to the third rule of thumb, and this is for loads in equilibrium. This is a common question. This option can be turned off or on for the entire connection. You'll have that option in the top ribbon. This option will define if you add forces on the support member, okay? My rule of thumb when reviewing models is the following. Keep it on if you have the reactions in the node from all the members, including the bearing member. An example is that you have the global analysis model and you have all the results from it. Okay, so you have the reactions also in your support member, for instance, a column. Okay, then my suggestion is that you keep it off because you are doing just delegated connection design, and you're only provided by the beam reactions. You don't have any information about the column or your support member. You just get the moments or shear forces from the members, and then in that case I suggest keeping it off, because sometimes I have seen that people is trying to artificially put the node in equilibrium, but then you're putting some forces that are not real. You are not sure that they are coming from the global analysis calculation, right? So in that case, instead of putting more false information or erroneous information, I'll just suggest to keep it off, okay? Again, I'm going to put some links here, and you can learn more about it, but this is my rule of thumb for loads in equilibrium, and hopefully it helps to make quicker decision when you're modeling connections for the new users or experienced users. Now, I will hand over to my colleague Johan so he can continue with the presentation.
All right, so the last 3 ways to reduce connection design time are all about reusing, grouping, and batching. We're going to go over how much each of these methods can speed up your connection design time. And here we'll go ahead and get started with the Web Connection Library. Now, this is an online database browser, and you can search over 1 million connections that we have ready for you to be using. You can simply set up the geometry, search, and filter the connections. Once you have found a connection that you want to use, all you have to do is open it directly in the connection application, download it, or see it online with our online viewer. If we move on to the middle here for the group and batch design, this goes in hand with our checkbot integration, and it allows you to integrate with your favorite FEA or detailing software. You can run your analysis in your FEA. Once you have your results, you can import your entire project along with those results. And once it's in checkbot, checkbot will group similar connections automatically so that you can reduce your modeling time. Here, by reducing the modeling time, all you have to do is model your reference connections within that group, and basically that model will be applied to the rest of the connections in that group. Now, for the desktop connection library and parametric templates, Here, the desktop connection library is different in a way that the connection library is within the application and you don't have to search through templates online. We have ready-made templates for you to be using within your project and starting from scratch. But another additional feature here within the desktop connection library is that you can build on to your own inventory, save connections, and also share them within your company. You can also build parametric templates for your standard or modular connections that might be repeated for different sizes of members. You can always create parametric templates, save them, and also reuse them. Now, if we go into detail for each of these strategies, we'll review basically different examples in which we tested these different methods and see how much time we can save with each and every single one of them. Now, again, we'll go ahead and get started with the web connection library. And in this example, we're basically looking at a moment connection. And the task was looking at a manual way of modeling this connection. So starting from scratch in the application, looking at possible templates, and from there, adding our right member sizes and the manufacturing operations. Now this is being compared against the web connection library where we're going to search for this connection, download it, make the necessary adjustments, and get it ready for the analysis. So we're just looking at a way from getting it from point zero to being ready for the analysis. Some aspects of this connection example involve an HSS 10 by 10 by 5/8 with a W section 12 by 53 for the beam. We are using common bolts, and some of the complexities in this connection can be the HSS member, multiple members coming into the node, looking at a custom plate geometry, and having a fully bolted connection for the beams. Now, we ran this test, we recorded basically each and every single method, and we timed the results. So here at the bottom, you can see basically the timing on both of these connections, getting them ready for the model to be analyzed. And at the top, we have the timing of each and every single one of them. When it came time to creating this connection manually, for an experienced user like myself, it only took about 15 to 20 minutes to model the entire connection. And that is taking advantage of the modeling tips and tricks that IDEA provided previously. Now, using the help of Connection Library, I was able to search and find the exact connection template that I needed. The rest of the time was basically spent adjusting the connection due to the difference in member sizes or plate geometry. Now, for this method, it only took about 7 minutes, and as you can see, we're still modeling this connection, whereas the Web Connection Library was already finished. And with this comparison in time, you can clearly see that you can save over 50% in time savings just by using our online database browser, which is Connection Library. Now, if we move on to our next topic, which is basically looking at grouping and batching involving our integrated connection design, we'll start by looking at this workflow. So this can be for your large scale projects or cases where you have to design multiple connections or looking at a very complex connection. We have Checkbot for you to be using this, where again, you can group and batch design. Now, the workflow goes as shown from the left-hand side. You can start in your global analysis, run your full analysis and look at the results. Once it's ready, you can then use Checkbot to bring in all that useful information. So things that you can bring in with this import are your geometry, cross-sections, and most important, the load combination results. Now, once all of this information is within Checkbot, similar connections will be grouped automatically based on topology, but you can also create your own custom groups here within the Checkbot application. Now, if we move on to our fourth tab, the neat thing here within grouping and within Checkbot is that you only have to model your reference connection once. What does this mean is whenever you create a group in Checkbot, one connection will be assigned as your reference connection. So this reference connection will be modeled. You will save that connection, and that modeled connection or that model will be applied to the rest of the connections. Now, let's say you imported your information into Checkbot, created your groups, and modeled your reference geometry for your connection. You can also get more efficient with this next step, which is the critical loading. Here is basically where the extreme load combinations are identified within the group and are applied for that analysis. So this makes your analysis time a lot faster because the group connections are already similar, so there will be a lot less load combinations that you will need to analyze for within that group. Now, again, you have all the necessary information now. You have the model, you have the results. Now you can run your analysis. And here in Checkbot, once you run your analysis, as you can see on the bottom left corner of this second row section, you will have a status of all your connections within that group, whether it passes, it has a warning that needs to be checked, or it failed. Now, if it failed, or you have a failing connection within that group, you can simply go into that specific connection, look at what's wrong, adjust for it, and rerun the analysis. Now, let's say you already have all your connections passing on your checks. Now, all you have left to do is print out your report showing that they passed. Well, here within Checkbot, you can also print a report for all the connections within the group. And because we do have a fully customizable report, this will help you show all the necessary information that you may need to show, whether it's a detailed report for every single connection or just a brief report stating whether the status of the connection is okay or not. Now, this will basically complete your workflow for you to be able to design your connections a lot faster. But the last part here on the right-hand side is one way in which you can take it to another level. So here, let's say you are working with some detailers. You have the option of exporting the connection as an IFC file, which can then be read by multiple other detailing software such as SDS2, Tekla, and Revit. Now, if you have a customer or other colleagues that need to see the connection in detail, you can always share that connection through our online viewer. So here, your colleagues, they do not have to have a license. They can simply create an account and view that detailed connection online. Now here, again, we ran another test for this integrated connection design and we have the results. So here we did a webinar not too long ago. So for those of you who are regular attendees here within our webinar, you might remember this project. But for those of you who are new to this webinars, we did create a project and presented it in a webinar not too long ago about Checkbot. We ran the analysis and looked at how much time it will take to create this project. So a quick outline of this project. This project had 118 joins with over 200 connections within this single project, and it dealt with basically a combination of simple and complex connections from steel to concrete connections. Now the table on the top left corner, as you can see, it shows the different activities that we had to perform for this project. So things such as importing the structure, designing the reference connection, and batching design the groups. We listed all of them and showed the total time for all of them. So here, based on our time, it took just under 2.5 hours for a project with 118 joins. Now, since this was in one of our webinars, we asked our attendees how long it would take for them to create that project. And as you can see on the bottom, over 80% of them said that it will take them 6 hours or more. And with a quarter of them saying it will take them over 24 hours to complete this kind of project. Now here you can clearly see how within Checkbot you can easily save at least 50% of your time by doing this workflow rather than doing it with other common practices. It can be with other analytical software or spreadsheets. Now here lastly, we're covering again the desktop connection library and the parametric templates. And these are another way of saving time. Could be direct or indirect way of saving time because with this option, you no longer have to start from scratch. You can use templates that are either shown by IDEA StatiCa or your own custom templates that you can save. So yes, here within the desktop connection library, you can save your own connection, create custom parametric templates, which is basically this display that you see here, shows you the availability of starting with one template and ending with different modular connections that might have slight differences in them or have different cross-section sizes. Now, aside from creating those custom parametric templates, Once you have saved them, you can reuse them on future projects. And now all of this basically allows you to keep consistency within your company. You avoid having to create different models and getting different results for each and every single one of them. And in the indirect way, it can also reduce the modeling learning curve for those of you who have maybe junior engineers or new engineers who are um, barely starting to use this application, but want to focus on looking at the results and viewing that everything is okay. So now let's go ahead and review the last 3 ways that we showed on how to basically reuse, group, and batch your connections for a faster connection design. Now we started with the web connection library, and this is an online browser with over 1 million connections. Here, all you have to do is set up the geometry, look for that connection. Once you find it, you can start using it right away in your projects. We also cover group and batch design, where we can use the checkbot integration for your FVA, bring in that project, group your connections, apply the analysis, and batch design all your connections and print the report for the connections within all your groups. And lastly, we covered the desktop connection library plus the parametric templates, how you can use the desktop version of connection library to use templates, save connections, share them with your company or yourself, and how to create basically different parametric templates for those modular connections or company sets. Now, last but not least, what we have here to present to our users is that now we have version 25.1 available. It's ready for our users to download, so head on to our website and download it. And here's some of the highlights for this new version is that now we carry the WT sections ready for users to use them from the AISC database. So now users no longer have to type in those exact dimensions. Now you can look and browse through them. In parallel with that, we now also have the ACI 318.25 code for the anchors in the connection application as well. So now if you have those projects that require those latest codes, now you can use this ACI 318.25 code with version 25.1. And as part of the checkbot efforts, now we have a new improvement here, and that is with the alignment of the members. Now you can automatically align your members to the top of steel, and they no longer have to be at the center line. So this improves your workflow a lot faster so that you don't have to go through every member and set up that exact offset. And lastly, we also have a new feature where now you can introduce plates in multiple planes of the concrete block. We have had some instances before where users wanted to create things such as corner or edge base plate connections that require multiple plates in different planes. This was not a possibility, but now with 25.1, you can get advantage of this new feature. Now, if you are curious about all the new features, improvements in version 25.1, we do have the full release notes in our website. So if you're interested in finding all that new information, just head on to our website and we'll have that information there. And with this, we can now look at the next steps for the presentation.
All right, looks like Johan got cut off there, but thank you, Johan, for all that good info. I'll steal the screen back here so we can see. So in summary, thanks for joining today. We walked through IDEA StatiCa and how that kind of compares to how you might be using hand calcs versus what you can do in IDEA and saving time on those different calculations. We looked at different operations for modeling and rules of thumb for faster modeling to kind of speed up that modeling process. And we looked at strategies to reuse connections that we already have or find them online and ways to group those for faster designs for ourselves and for the rest of our companies. And then we took a quick look at the IDEA StatiCa 25.1 highlights. So with that, we'll go into a little bit of a Q&A. You can still input questions on the right side in your control panel there. So feel free to put in some questions. We also had quite a few come in, so we'll start hitting on those. So let's take a look here. A few things I guess I'll mention that we always get questions on is one is PDH certificates, excuse me. So those will get automatically sent out by GoToWebinar. So since you were part of this today, that'll get sent out to you. The recording, once again, is going to be available on the website in a day or two, so jump back on and check that out. And then if you want to grab the handout, you can also either grab that in the control panel underneath the handouts, or you can also access that online here in a couple days once we update that. So those are all on there. So to start off with questions, there was several questions about the online connection library and how to access that. So there's a few options. One, there's a direct link, you can just get there, but really the easiest way is just as you start the software, the initial screen, up in the top left-hand corner where you're used to clicking connection, there's a button just to the right of that that says connection library, and that'll get you right to the online connection library, and that's where you can access all the millions of connections that are up on there. So that's one to be aware of. There was a question about does the software run AISC calculation checks when we're looking at connections? So Andrea or Johan, do you want to answer that for us?
Hi, Jason. Thank you. We do provide the AISC checks. These will be the component checks. And for plates, we do work with stress analysis. So the plates will be per the FEA, and then the plates are by the component checks, which is basically our method, the CBFEM, component-based finite element method.
Perfect. That's right. We kind of do a mix of both. It really gives us the best flexibility to design all connections there. So another question that came up was, we were showing AISC codes today, but does the software handle Canadian codes and other codes? And the answer to that one is yes. So we cover most of the worldwide codes. We started in Europe, so we have Europe covered fairly well. We do also have Canadian codes in there as well as quite a few others. So you can explore more online if you're interested in those. There was a question about light gauge and if we can use light gauge within the software. Johan, do you want to take that one in terms of looking at light gauge steel in the software or cold form steel?
Right. So in IDEA StatiCa, you are able to model light gauge shapes or cold form rolled shapes in IDEA StatiCa. We do not provide the specific checks for cold form, but we have had some users previously who use the software just to check for the stresses and verify their analysis.
Awesome. There's one question here about the online connection library, and I think they're asking about if they're available, for the offline mode they're calling it, but available for within the software. So yeah, when you have it online, you can directly download that from the online connection library and have it on your computer. So from there, you can work with it, modify it as you need to design your connection. There's another question asked about free training courses or training courses. So we do have quite a few different options when it comes to training. We have some free options online, which is, really we have a whole database of information online that you can use to learn the software in terms of articles, different, webinars from the past, all that kind of good stuff. We also have a free campus course, or multiple courses that go through steel design, concrete design, lots of different options there. And then we also offer paid trainings that are live virtual trainings where, Johan or Andrea or others will come in and do a training for teams. So that's also available.
We also had a question whether we can import custom shape cross sections for things such as historic, retrofitting, things like that. And the answer is yes. We are able to import custom shapes not only for the cross sections. If you have, again, any custom geometry on your plates or things like that, you can always import those. But again, we also offer the options where you can customize and edit your common rectangular plates.
Johan, there's a question here about is bolt prying effect considered in the analysis? You want to answer that one?
Yep, definitely. So here within IDEA StatiCa, those limit states are essentially checked within the FEA analysis. Basically, if you have a connection with lower stiffness compared to a connection with higher stiffness, you will be bound to see those effects of prying actions in a connection with a lower stiffness. So although you may not get those checks, you will see those as part of the results. So if you have a connection that is low in stiffness, you will see a failure maybe due to those prying actions presenting higher forces than the regular bolt forces.
That's right. Yeah, we just are checking it inherently in a different way there. What about, there's a question asking, are we limited to only using parametric connection modules or templates, or can any type of connection be modeled from a combination of cross sections, welds, bolts? So basically, are they limited to the initial templates that are shown in the app?
No. So these templates are just a way for you to get started. So once you open any template that you find, you have the availability of adding more members, removing members, adjusting the connections, removing parts of the connections. So again, it's just a way for you to get started. And one of the neat features here with IDEA StatiCa 25.1 is that, let's say you have a very complex connections with multiple members coming at the column. With the connection library, you can apply different templates for different connections within that single node. That way you can build your connection or your complex connection a lot faster out of multiple different templates.
Perfect. There's a question here asking, says, does this program help with steel to concrete connections? And then they're saying more specifically with cast in place anchors or adhesive anchors.
Can you repeat that again?
I can answer that one. So yeah, for connections with cast in place anchors or adhesive anchors, when we're connecting between steel and concrete, IDEA StatiCa can solve those. So most of that is done within the steel connection software that we looked at today. But if you're looking at an adhesive solution, then we have a separate module called Detail that we use. So we can combine those in one process and analyze that all together to understand what's happening with an adhesive anchor.
And one more question about connection library, and that is how to make a desktop connection library for future uses. Basically, I'm guessing referencing to making your own inventory. So the way that it works is if you have a connection that you're using typically for future projects, within the connection application, we have an option where you can publish your connections to your company. That way you can share it with your colleagues, or you can keep it personal. So that way, once you save those connections, it takes a couple of seconds. As soon as they're saved, they're ready to be used by, again, your colleagues in the company or by yourself, and they will be available right away in the desktop version.
There's a question here about, it says, are you able to save custom material properties such as A304 stainless steel? John, can you kind of describe how you can create custom materials or members even?
You can, so in the application, we have multiple tabs for checking, designing, but we also have a tab for our materials. So we do carry a certain database of materials, sizes, bolt dimensions, things like that. But if any of these parameters fall out of what you're doing, you can always import those. So if you have specific materials, we have an option where you can import those material properties. If you have smaller bolt sizes or oversized bolts, you can always import again, bring in that information if you have that with you. For cross sections, again, as well, you can import custom cross sections, built-up cross sections, or even complex geometry cross sections.
There's another question just asking about flange copes and if you can model different types of flange copes. So that we can definitely do in the software using the operations to cope those flanges or columns. Here's another question, and it asks about using IDEA StatiCa to analyze composite members. So, scenarios where steel might be embedded in concrete, like a steel member. And so, I think to that, we can't necessarily handle that quite yet. we've made a lot of advances lately with kind of combining steel with concrete and looking at that with anchoring. So the hope is to have that in the future. At this point, you know, it's still probably a ways off, but hopefully someday here. Any other on there, Johan?
Let's see. I think we covered the main ones. Again, if you have, we did see that there were some questions that maybe some users or users with trials have asked questions about connections. If you happen to have any connections, whenever you go to our website, you can always go to the portal and submit a case. That's where we are able to help you the fastest. You can always submit your question along with the connection and we can get back to you. But not sure if there's any other interesting questions that we can cover, Jason.
Yeah, I was just looking through. I think that pretty much covers it. Some of them are getting more specific, so we can reach out to you and address those offline here. But yeah, I think with that, we can wrap it up. I will mention we have a webinar coming up. We're going to skip November just with Thanksgiving and everything going on, but early December, keep your eye out. We'll have one probably that first week of December, and that will be the final one for the year for us. And if you're in Colorado, I will be at the SCA of Colorado Fall Seminar next week, so come say hi. And other than that, thanks for joining today. Have a happy Halloween. Don't eat too much candy, and we'll just catch you on the next webinar. Everybody have a good day. Thanks for joining.